Uh, so we're going to look at polymorphism. I'm going to be working actually from the link today instead of doing our shape hierarchy like we did yesterday. So if you want to click along with that, follow along with me, that would be wonderful. Okay, so topic, polymorphism. This is like, in my opinion, this is basically the culminating part of this whole unit is polymorphism. You can't get to polymorphism if you don't know inheritance, if you don't know subclasses, if you don't know super, and stuff like that. So polymorphism, kind of the crowning jewel of this unit. Speaking of this unit, I'm looking at my notes here. We've got one more lesson tomorrow. And then next week we'll be doing a project for a couple of days, at least Monday through Wednesday, maybe even further than that, where we'll be creating Pong using inheritance and processing. So Monday through Wednesday at least we'll be doing that project. And then on Thursday or Friday next week, it is my plan to give a unit test. I would probably plan on Friday the 28th of February, but that's kind of what I'm looking at there. So polymorphism. Okay. Today is the 20th to 2020. Okay. So polymorphism. You know, what does it mean? Well, really polymorphism means many forms. Those are the two roots, but that's too general for computer science. But I'm going to write this down. Many forms. Now, let's try to come up with a better, more generalized, well, less generalized, I should say, definition based on what we did yesterday with our shapes hierarchy, and maybe the homework that you looked at last night. Instead of just saying many forms, well, what takes many forms when we're talking about polymorphism in computer science? Many forms of what? Well, like when I was just tracing through that question, when I looked at method 1, I had to determine which method 1 to call, because there were many forms of method 1, and there's many forms of method 2, and maybe a different way to put polymorphism in a computer science kind of context is a method may take on several different, I'm going to write the word implementations. If you don't know what implementation means, I'm just talking about how the method is done, how its body works. So a method may take on several different implementations in its subclasses. So yesterday we looked at the area method, for example. Area was implemented differently in rectangle, in triangle, in shape as well. So that area method was polymorphistic. It took on many forms. Perimeter took on many forms. Two-string took on many forms yesterday. So a method may take on several different implementations in a subclass. How do you know which form you're going to take on? Well, that's kind of what we have to talk about, and that's what your assignment was all about last night. So maybe we'll keep reading. Nope, wrong spot. Here we go. Maybe we'll keep reading. It says, in Java, it means that the method that gets called at runtime when the code is run depends on the type of the object at runtime. That sounds like we should include that. What did that say beautifully again? The method that gets called at runtime depends on the type of the object at runtime. Okay. The method that gets called depends on the type of object. Now, don't worry about the word runtime too much right now. We're going to talk about that a good amount in just a minute. But the method that gets called depends on the type of object. As you guys saw when you were looking at blue, flute, shoe, and moo, or whatever you were trying to figure out which method to call, you had to determine what type of object it was. The method that gets called depends on the type of object. So it says this is similar to a toddler toy that has pictures of animals, and when a handle is pulled, an arrow spins. Did anybody have one of these when they were younger? I did. I don't know about you guys. There's also like a speak and spell one where you would pull on it, it would spin around, and it would say pig, P-I-G, or something like that. And then it would even make a, I don't know, what's a good pig noise, like something like that. When the arrow stops, the toy plays a sound associated with that animal. So the animal sounds, that's a polymorphistic method. Depending on if you get the goose, what's a goose? A turkey, a mouse, whatever that is. What animal is this? Smiling something. A duck, which, you know, that's my duck call, thank you. An owl, hoo-hoo. A bunny, I don't know what a sound a bunny makes. Ribbit. A cat, meow, etc. Similar, yes. Okay. It says if you were simulating this toy in software, you would create an animal class that had, don't worry about this abstract, make noise method. Each subclass of animal would override the make noise method to make the correct noise for that type. This type of polymorphism is called inheritance-based polymorphism. You have a common parent class, but the behavior is specified in the child class. Okay, so this is what I wanted to write down. This is something we've talked about before. In Java, an object variable has both a declared type and an actual type. Let's write this down here. So I'm going to make an object something like this. Declared type, object name equals new actual type. So we've looked at doing something like this before when you're creating objects, but there's a couple things we have to discuss. This declared type, this first of all must be a, actually let's try it like this, must be the same class as the one on the right, or what? Yeah, or a superclass, or a superclass of the one on the right. So whatever this declared type is, it must be the same type as the one on the right, or it can be a superclass on the one on the right. Similarly, the actual type over here, I'm just going to, I know I'm kind of doing it overkill here, but I'm going to say must be the same as the one on the left, the class on the left. And you can say or a subclass. And if Annie were here, she'd tell us or it passes the is a test of the one on the left. There's some other stuff that this declared type tells you. The declared type tells you which methods you can use. Tells you which methods you can use. So if I make an object like this, where the class on the left and the class on the right are different, I can only use methods that are in the class on the left. So, for example, if the class on the left is object and the class on the right is string, I could use toString because object has a toString. I could use equals because object has an equals method, but I would not be allowed to use substring because object does not have a substring method. I would not be allowed to use index of or anything like that. So when you make an object like this, you can only use methods that are in the declared type. However, I'm going to say the one on the right tells you which class to get method, body, or implementation from. Now, again, if it says object O equals new string, and I try to do the toString method on that object O, I will get the toString implementation from the string class, the actual type. Using the example they had with the speak and spell, or the animal sounds one. If it says animal A equals new cat, and I do A dot animal sound, it'll use the animal sound from the cat class because that's its actual type. Now, what if cat doesn't have a animal sound method? Where would it then get the implementation from? It's superclass. And would keep looking up the superclass like the question Daniel had me working through. So the declared type must be the same class as the one on the right or a superclass, and it tells you which methods you can use. The actual type must be the same as the class on the left or a subclass, and tells you which class to get the method body from. Let's keep reading, and I think this will make more sense as we go along here. I'm going to skip their part about list because I think it's unhelpful. However, I'm going to scroll down to where it says the variable message if you'd like to read from there with me. It says the variable message declared below has a declared type of object and an actual type of string. Since the declared type of message is object, the code message.indexOf will cause a compiler error since the object class does not have an indexOf method. Remember, the class on the left, the declared type, tells you which methods you can use. Object does not have an indexOf method, so I cannot call indexOf on message. What other methods would I not be allowed to call on message? Do you think there's a substring method in object? No. I couldn't do dot to uppercase. I couldn't do dot to lowercase. I couldn't do basically anything that's specific to a string. I can only do stuff that object and string both share, something that string maybe overrides, or something that string inherits from object. So using toString, I could also do dot equals, for example. It says at compile time, the compiler uses the declared type, the one on the left, to check that the methods you are trying to use are available to an object of that type. The code won't compile if the methods don't exist in that class or some parent class of that class. At runtime, the actual method that is called depends on the actual type, the one on the right, of the object. Remember that an object keeps a reference to the class that created it, an object of the class called class. When a method is called at runtime, the first place that is checked for the method is the class that created the object, aka the actual type. So as I said in the notes here, when you go ahead and call a method on obj name, you will actually look for that method inside of the actual type. As long as it's a legal call, you'll look for the method inside of actual type. If it doesn't exist in actual type, then you'll look up the hierarchy until you find it. If the method is found there, it will be executed. If not, the parent of that class will be checked, and so on until the method is found. In the last lesson on inheritance hierarchies, we were actually seeing polymorphic behavior at runtime in the following ways. Polymorphic assignment statements such as this. What is the actual type of S? Rectangle. What's the declared type? Shape. This means that I can use any methods that are in shape, but I will get their implementation from rectangle. So if you can recall kind of in the back of your head, remember yesterday that shapes did have an area method. This would be legal because shape had an area method. However, where would it get the implementation from? Rectangle. So two things are going on here. First of all, I'm going to say legal because area is in declared type. And then second of all, we'll get method body from rectangle, which is actual type. So remember, I think shape yesterday just returned 0.0 for the area of a shape. But since the actual type is rectangle, it'll go to the rectangle class and use that implementation or that method body to calculate the area. Am I making a little bit of sense? Okay. A modicum of sense? Okay. Sounds good. A quantum of sense. That'll be the new James Bond movie. Instead of Quantum of Solace, Quantum of Sense. Starring Mr. Foster. Polymorphic parameters such as print shape being called with different subclass types, polymorphic array, and array list. This is what we did majorly yesterday, is we had an array list of shapes and we put a bunch of them in there. Now, This behaves similarly to what we just wrote on our note sheet. What would be the declared type of all the elements in this array? Shape. The declared type is shape. What's the actual type? Well, it depends on what constructor you use to be created. The rectangle's actual type is obviously rectangle. Square's actual type is obviously square. So since this uses shape, yesterday we were able to do stuff like this. We could say for shape S in shape array. We were able to do, I don't know, print out, S dot area. And that's legal because the area method exists in shape. Where's it going to get the implementation from? Depends on the actual type. Same with if I did just print out S. What method is being called there? The toString method. Who's toString? Well, again, it depends. It depends on which the actual type is. We obviously know that every shape is going to have a toString method, not just because it's in shape, but because toString exists in the object. So everything's going to have a toString method. Which toString do you call? It depends on the actual type. Do people have questions so far? Okay. All right. All right. Okay. It says in all of these cases there are no errors that compile. Oh, yes.
So what if?
Oh, I didn't even do it. Gosh dang it. Go ahead.
Okay. So what if you want to call a method that the subclass has?
You can do. So there's a couple different ways you could do that. Let's say I'm just using this example right here. I think yesterday we had a rectangle that had a diagonal method. I could do something like this. Since what's the actual type of S? Rectangle. I would be allowed to do something like this. Where I'm casting S as a rectangle object, which means in that case I would be allowed to use any methods in the rectangle class. Now, I would not be able to cast something that's a triangle as a rectangle. So usually if you do some casting like this, you might tack on something like if S instance of rectangle. And then you do the casting. So this would see what the actual type of, and usually you'll use the subclass over here instead of the superclass. So I would see if the object S is a rectangle, and then if it is, if its actual type is rectangle, then I would do a cast on it, and then I could do that diagonal thing. I could even do it down here with this shape array. If I had an enhanced for loop, I could see what the actual type is and then do a cast on it. So I think maybe we'll talk more about that later today or tomorrow, but basically the parentheses look terrible here, but essentially I have to cast S as a rectangle first. That's why the parentheses are all around S here, and then I could call a method that's only existent in rectangle. Does that kind of make sense? Okay, good question. It says in all these cases there are no errors at compile time because the compiler checks that the subclass is a superclass relationship is true, but at runtime the Java interpreter will use the object's actual subclass type and call the subclass methods for any overridden methods. This is why they are polymorphic. The same code can have different results depending on the object's actual type at runtime. That's a great definition of it as well. All right, there's some questions. How do you guys want to do these? Maybe with a partner, and then we'll go over the answer together, or do you just want to do them as a group, or? You do them and you, I do them and you watch. Let's see if we can do the AP test that way. That sounds fun. All right, let's look at this first one here. 961. It says, what is the output from running the main method? Oh my gosh, what is this? Last night's homework? Am I right? All right. Here's what always helps me is just thinking about the hierarchy here. It looks like shape is the first thing in the hierarchy, and then it looks like rectangle and oval are subclasses of shape, and then it looks like square is a subclass of rectangle, and it looks like circle is a subclass of oval. So that's what I see so far. Is that what you guys see as well? This is what I see so far for this question. Okay, so a square is a rectangle is a shape. Got it. All right, it looks like, okay, here's our declared type is shape. Our actual types are shape, rectangle, square, and circle. For each one, we go ahead and do the what method. So for the first one, its actual type is shape. When I call what on a actual type shape, let's see, does shape have a what method? It does. It prints out just shape with a space. So I'm thinking for this first one, it's going to print out shape with a space. Then the next one has an actual type of rectangle. When I do rectangle dot what, the rectangle's what method prints out rectangle, it looks like. I hope I don't make a mistake here, but no guarantees. The next one has an actual type of square. Oh, square doesn't have a what method. Where's it going to get its implementation from? Rectangle. So it's going to say rectangle again, I think. And then the last one has an actual type of circle. No ovals in this one, huh? Circle has a what method that prints out circle, it looks like. So I get shape, rectangle, rectangle, circle. Is that correct? That is right? Nice. I don't want to answer it because it won't like it. Oh! I guess we should watch out for compiler errors. I totally didn't even think of that. That's so silly of me. Since they're all shapes, this is only legal if shape has a what method. It does, though. So I'm guaranteed that all subclasses of shape will also have a what method. Either they inherit it or they override it. So I can't even remember what the answer was. Shape, rectangle, rectangle, circle. Was that? No. Yeah, okay. D. All right, we want to do another one. Sounds good. What is the output from running the main method in the student class? Let's check this one out. I can zoom in a little bit. Okay, the main method student. So the declared type is student. The actual type is grad student. Oh, I remember this question. I don't remember the answer, but I remember this question. S1.getInfo. So this is a grad student. So it's going to get the S1.getInfo method from grad student. Does grad student have a getInfo method? No. So where are we going to get info from? Oh no. Ian, this is the thing that we went back on so many weeks ago and I forgot to even talk about it again. That's okay. GetInfo. The GetInfo method doesn't exist in grad students, so it goes up to the GetInfo method from the class student. All right. I think I may have told a story a few weeks ago that was incorrect, and Ian corrected me, and maybe I never got to it. Which getFood method is going to be called here? It's going to be grad students. I think a week or two ago, I might have accidentally said it was students. This is just applying to what is this object's type. This object's type is grad student. So when I call getInfo, well, getInfo is going to be inherited from up here. And the getFood method, this .getFood, since its type is grad student, it's going to use this getFood method. So I believe it's taco. Is B the correct answer? I really should be looking out for compile time errors. I know there's not going to be an issue calling getInfo because I inherit getInfo. I know there's not going to be a runtime error because a grad student is a student. So the idea here is it gets getInfo from student, and then when I say this.getFood, it uses the getFood method of whatever the actual type is. The actual type here is grad student. Yes, Ammon?
What if you wanted the students get
I don't know how to do it. I thought it was this, and that's not how you do it. Did you hear Ammon's question? Ammon asked, how do you actually call How do you actually call students getFood method, right? How do you actually call get pizza? I don't know. That's my question 3. Any ideas, maybe for more of our experienced people? How can I actually make getInfo called this getFood method? That. Please, this.
Can you
Would super do anything?
Super, like this.
By
Super.
this dot super dot?
Could you create
Yeah,
it?
could you do that? This dot super dot. Is that possible?
Super dot? I don't...
This dot.
If you don't know, if you guys don't understand, the question we're asking is, well, okay, if this one's going to be taco because it's calling the get food method of the actual type, how could we get it to call this method? How could we guarantee that it's always going to call that get food method? Because if I do super dot, it's gonna super class of student would be object, and object definitely does not have a get food method. Oh, I see what you're saying, because this is...
The grass student. And if
I like, hey, I need to know. Let's check it out. I got JGrass open right here, baby. Let's see. Do I have a, hold on. Let's check it out. Documents. Hopefully I don't have a student dot. Don't even talk to me. Okay. Let's see. So if I do this dot super dot, I feel like it's really not going to like that. For many reasons. I don't think it's going to like that because object doesn't have a get. Yeah, it's going to say, yeah, it doesn't see get food in the superclass. Any other ideas? How could I force it to use the get food method of student? Yeah, Hammond?
Could you create another student object with everything to your grad student?
Oh.
I don't know if
I think I know what you're saying. Where you just like use, yeah, you create another student in here and call that get food? Yeah, Dana? If I make it static? Let's... Oh, and then do student dot. Student dot get food. Oh, but then I'm so far down the rabbit hole at this point. Any other ideas? Make everything static? What if I just make... Hold on. Oh, we're just not going to print now? Why? Because there's no print statement? Don't tell me my job. Okay. No. Yeah. Okay. Okay. Here's an interesting result. Maybe it's not so interesting. Matt, that's what you're gonna say. Sorry. Did you have your? Is that what you? Oh.
No.
Oh, okay. Okay. Matt, that was the answer. So why, if I make it private? Any ideas why it might work if I make it private? Well, when you make a method private, it doesn't get inherited. But still, when it says this dot get food, it just says get food. Wait, but remember, when you call a method, it's implicitly saying this dot. Or any instance variable, it's saying this dot implicitly. I need like a 2-minute break. Why don't we go stretch our legs? And I'm getting a headache. Let's take a quick 2-minute break here. Stretch your... Next question here. We have a car class and a race car that extends car. So race car is a car. That's what I see. It looks like we create a car named car that uses cars constructor. Its actual type is a car. So it takes 5 and it makes the fuel equal to 5. So right now our car object has a fuel of 5. I'm going to kind of try to keep track of this here. Car has a fuel of 5. Then we also make a fast car, but its actual type is a race car. So it's going to use race car's constructor. Let's see what race car's constructor do. Well, we send in a 5 here, and it calls super's constructor, but it sends in 2 times 5, which is actually 10, to the superclass's constructor. So this 10 gets sent up here. So now our fast car, is that what it's called? Yes, fast car is going to have fuel of 10, is what I see here. All right, let's continue on. Let's see what happens next. Then it says car.display. Well, car is a car, so I'm going to use the display method here. It's going to print out the fuel in a space, so it'll be 5 in a space. Then it's car.addFuel. There's only an add fuel method in car, so I'll use that add fuel method. It'll add 1 to the fuel, so it's 6 now. Then it does display again, so it'll print out 6. Then it does fastcar.display. Well, race car, its actual type does not have a display method, so I'll use the one that it inherits from up here. So it'll print out the fuel, which is currently 10. Then it'll do add fuel. Well, there's no add fuel method in race car, so I'll use the one that it inherits up here. Add 1 to the fuel to make it 11. Then it'll do display again. There's no display inside of race car, so I'll use the one that inherits. 5, 6, 10, 11, I believe, is the answer there. Is that a true story? I hope you guys are getting what I'm doing with the tracing and where the methods are being called from. Okay. These are always the questions they try to get you on. Not the fun questions. It's the boring questions where you're trying to figure out what the heck is going on. It says, given the following class definitions and a declaration of book B equals new dictionary, which of the following will cause a compile time error? Now, when it says compile time error, it basically means we are trying to use a method that does not exist in the book class. So if we're trying to use a method that only exists in the dictionary class but not book, it'll give us a compile time error. Let's see. B.getISBN. That is in book. That is legal. Because I've declared it as a book, so I can use any methods that are in book. So that one's legal. B.getDefinition. GetDefinition does not exist in book, and book does not have a superclass that's going to get GetDefinition from. So I think B is the answer. Is that correct? Okay, remember when you make an object like this, superclass and subclass, you can only use methods that exist inside of the superclass. That's why yesterday we could not do something like s.diagonal, because not all shapes had a diagonal method. We could not do something like s.hypotenuse, because not all shapes had a hypotenuse method. You can only use methods that exist in the declared type. Since it's declared as a book, I can only use methods in book. And C gets back to what Daniel and I were talking about a little bit ago about casting. I should probably put something on our notes about casting. Let's put it in here. Something about casting. Casting an object as a subclass type. So I'm going to say it is legal to cast an object to its subclass type as long as that is its actual type. AKA which constructor it was made with. So, for example, let's do something like this. If I say shape T equals new triangle, I don't know. I think our triangle constructor wanted 2 doubles yesterday. So if I say shape T equals new triangle, the declared type is what? Shape. The actual type is triangle. If I wanted to use the hypotenuse method, T dot hypotenuse would be illegal. I'm going to put in maybe a comment and, no, I'll just, okay, so this would be illegal. If you don't know why, essentially the issue is hypotenuse method is not in shape. You can only call methods that are in the class on the left there, the declared type. So since hypotenuse is not in the declared type, I cannot go ahead and call t dot hypotenuse. However, if I want to make it legal, I can cast it as its actual type. The actual type is triangle, so what I could do instead is the following. I'm going to write the same code, but then I'm going to add a little bit of room here for a cast. So I could do something like this. Need two pairs of parentheses. Triangle. That would be legal. Why is it legal? Because first of all, I'm casting it as its actual type, so that's fine. Second of all, I'm calling a method that's in its actual type. So you can cast stuff down in its hierarchy like that as long as it's legal. Now, if I said something like shape t equals new rectangle, you think I could cast like that? Heck no. If I said shape t equals new polygon, I wouldn't be able to cast it down to a triangle. I can only cast it as long as it's its actual type. So I can do that. Basically, it first makes t into a triangle. It makes its declared type into a triangle just temporarily, and then I can call the hypotenuse method. And you could add an if instance of in front of it if you wanted to. You could do something like if t instance of triangle beforehand just to make sure it's legal. You could do something like that. Okay. Questiones. Were there any more of these? Oh, there is one more. Thank goodness. One more here. My favorite. Let me zoom out. You know it's a good question when you have to zoom out to see the whole thing. That's the mark of a good question if I've ever seen one. It says, assume that the following declaration appears in the client program. When it says client program, it's just like a tester class, just something that has a main method, a different class. Base B equals new derived. What is the result of B dot method 1? Well, let's make sure this is legal first. Derived is a base, so this is a legal declaration. The declared type is base, the actual type is derived. That's all good. Is it legal to do B dot method 1? Only if method 1 exists inside a base. Method 1 does exist inside a base, so that's legal as well. So when we call B dot method 1, I'm going to use the actual type to find method 1. Here's the actual type. Derived. So I go down to method 1. It immediately says do super. Oh, I should use my format here. Immediately says do super dot method 1. Okay, so I'm going to do this. Super dot method 1 is up here. That prints out an A. That's done. Then it says call method 2. Which method 2? Well, again, you're using the actual type. Method 2 would be from the derived class if it exists. It does. So I go down. I think we've done a question like this before. Method 2 is down here. This immediately calls super dot method 2. Oh, gourd. Super dot method 2 is up here. It prints out B. Then when it's done with that, let's trace back now. Tracing back. We just did super dot method 2. That's done. Then we print out D. That's done. We trace back. We just finished method 2. We trace back. Then this is done. We print out C. I believe the answer is A, B, D, C. Is that true? What was harder, this question or the ones you had last night? Last night? So you've been through the fire. You've been forged in the flames, and you are ready to rock. Is it ABDC? Oh, good. You know what? I was going to do this second part of the shopping cart thing, but instead of that, why don't I take a minute to answer any questions you guys might have first? Mm, 46 seconds. Yeah, Maya.
So as long as you cast something in front, you can use a method even if the declared type doesn't have it inside.
Yes, but just make sure if you do that cast, you have to be sure that the actual type is whatever you're casting it to. Does that make sense? Cooper. You have some time. Maya, that was a great question. Yes or no? Alright, yeah, I know what you're thinking. No, you're not. Alright, I do have an assignment. Why don't I just give you the rest of the time to work on it? That seems fair. Okay. Sure enough. If you liked last night's assignment, you're going to love this one. If you didn't like last night's assignment, well, you're going to get some more valuable experience and practice. Let's say that.
Good job.
I am leaving you the last 10 minutes to work on this. Whenever you get it, you're more than free to start working on the assignment here. And it's just, again, more of the polymorphism stuff, declared type, actual type, figuring out which method to call and where, and all that jazz. So, it's a physical worksheet that you can write on. Maybe that'll be helpful to some of us that struggled on last night's assignment. So you can do all the tracing stuff that I like to show. You're more than welcome to do that. And that's your homework, and you have the last 10 minutes to work on it.